This is a tutorial video for one of the types of questions that could appear on a Willamette Promise exam. This particular question is asking you to fill in the isotope notation for the stable, most abundant isotope of bismuth. Kind of interesting wording here, but it can be a little bit tricky, so I want to go over the format of this question, and then you have a similar one that you can do on your practice assignment. So follow along with this one, and then hopefully you'll be able to figure it out for yours. So one thing that we need to focus on to start out this problem is kind of remind ourselves what these letters represent. So that remember that the top number is the mass number, and the bottom number is the atomic number. So if you don't remember that, go back to the chemical symbols video and you will get a little refresher on that. But so what it wants you to do is actually figure out the numbers. What numbers go where A and Z belong. And the other thing that's important here is that it's the most abundant isotope. So remember that on your periodic table, you have atomic masses, right? So if we find bismuth on here, it's right there. Remember that that number, 208.98, that's the atomic mass. And the atomic mass takes into account all of the isotopes of a particular element, and then it will take the weighted average, and that's why we get a decimal number here. Looking back here, the mass number, recall, has to be a whole number. It's an actual count for a specific isotope. It's a count of the protons and neutrons that are in the nucleus. And so we need a whole number here. Our periodic table only gives us the atomic mass, which is not a whole number. So we kind of have to do a little bit of work here. And this particular problem doesn't really give us, I think it doesn't give us enough information. So we're just going to do the best we can. When it says to use the most stable isotope, when you look at this atomic mass, it's really, really close to what whole number? Hopefully you said 209, right? 208.98 is really close to 209 as a whole number. So since it's not giving us any other information, that's the best we can do, and we'll just say that the mass number is going to be 209 for the most stable version of bismuth. And that is represented in the atomic mass because it's really close to that number. So there might be a mass number for a different isotope, maybe a 208, but it's not as abundant. And that's what's making it slightly lower. Okay. Sometimes it'll give you more information, and it would be better if it said the two versions of bismuth and which one's the more abundant one. So you'll see questions like that too. This one doesn't give us the information, so we'll just pick the nearest whole number to the atomic mass. Okay. And then the atomic number, that one's easier. When we have bismuth, we just look to the atomic number, it's 83. So we'll fill that in for Z. So we have the mass number and the atomic number. So that's actually the first part, but you do have to fill in those numbers. So the second part is filling in this table below for the isotope that you just determined. So again, this is a review of chemical symbols, so it should be pretty easy. You just have to remember the little tricks. So for example, protons, the number of protons is the same as which number? The atomic number. So the atomic number always tells you the number of protons. It will always, always, always be the same. The number of neutrons, you'll use the mass number, remember, because the mass number tells you the number of protons plus the number of neutrons. So you just have to do a little simple subtraction. This has the protons and neutrons together. Here you have just the protons. So subtract those, and you should get 126. So we get 126 neutrons. Electrons, kind of tricky here. It doesn't give you any information about a charge. So when you're determining the electrons, you should always assume that the isotope is neutral. And if it's neutral, it means that the protons, which have a positive charge, and the electrons, which have a negative charge, should be the same. They should cancel each other out if the element is neutral. So we're going to say 83 electrons to balance out the 83 protons. Then there's a little extra question here. Now it does give us a charge. So this was electrons for the neutral one. Now it's asking, what about electrons if it had a positive 3 charge? So you just have to realize, well, if it's a positive charge, does that mean you lost electrons or gained electrons? It means you lost electrons, right? The protons are winning then, and the protons in this case are winning by 3. So for this number, 83, in order for the protons to win by 3, we need to reduce this by 3, and that becomes 80 electrons. So now you have 80 versus 83. Protons are winning by 3, which gives us a positive 3 charge. Okay, so it's just one of the types of problems. It's a lot of just the chemical symbols review, but this piece is probably the trickiest, just figuring out how you get that whole number mass number from the atomic mass on the periodic table. So basically the short answer is round this to either the nearest whole number, if you're not given any information about the different isotopes, or round it to the isotope mass that's closest to the atomic mass. So if you have questions about that, let me know.